Hello and welcome to the presentation, Essbase Aggregate Storage Option, New Features. In this presentation you'll learn about the Aggregate Storage Option databases referred to as ASO and some of their important new features in the releases since it was introduced. My name is Craig Messenring and I work for HCG. We provide consulting, training, and product sales in the Oracle BI EPM area, specializing in Essbase. We're an Oracle certified partner, an approved education center, provide on-site training, virtual training via the web, and custom education. First, we're going to discuss a number of things like why was ASO developed, what were the new features along the way, meaning since it was developed in version 7, and what's new in Essbase 11 as far as ASO goes. Things like partial data clearing, ASO being a target of partitions, new MDX functions, right back to level 0, custom calculations, MDX function templates, and so on. So first, in order to get a full understanding of the new features of ASO, it's important to take a look back at why ASO was created in the first place. Block storage databases, also referred to as BSO, fit very well to specific types of applications, mostly financial applications that tend to have dense data, meaning there's likely to be data for most of the intersections of the multiple dimensions in the databases. However, BSO databases don't do a very good job on applications that have extremely sparse data. Those kinds of databases usually require very large outlines, whether we're talking about the number of dimensions or the number of members in the dimensions, and they require quick batch times where loading and calculating of database is needed on a rapid basis, and where data volumes, besides being sparse, are rather immense. But in simpler terms, BSO databases, block storage, start to have performance problems once they grow beyond 7 or to 10 dimensions, and especially when the numbers of members in those dimensions start to grow. To accommodate applications that do have extremely sparse data sets or have extensive dimensionality or small update windows, ASO, Aggregate Storage, was developed. ASO was introduced in 2005 in version 7.1 of Essbase and was designed at that time for very large, mostly read-only, meaning no write back to the database, types of applications. It supports much larger dimensions, meaning more members, than BSO, as well as a greater number of dimensions. ASO allows for greater scalability, some up to 10 times on average more than BSO as far as the size of the database goes. Data load and calc times are approximately 100 times faster on average than a BSO database, and all of this you're able to do while having a smaller footprint, taking up much less space, up to 20 times less space than a block storage database. So ASO enabled Essbase to go beyond its core strengths of business data calculations and analysis and into other parts of the enterprise like customer analysis, product analysis, and market analysis, where massive data volumes and the need for data mining might be required. Here are some typical Essbase applications and requirements used by various businesses. The ones in the boxes are generally considered better suited for aggregate storage implementations. What you see here are some samples of the different types of applications and requirements that these applications have. Generally speaking, block storage is more suitable for the financial applications like sales forecasting, profitability analysis, and financial consolidations. And ASO is better for operational data like customer analysis, procurement analysis, and logistics analysis. When ASO was first introduced in version 7.1, there were limitations that caused it not to be widely adopted. For example, you could only load data into level 0. The loading of that data, the performance of the loading of that data was not up to par. There weren't any time balancing features that you may have been used to in block storage databases like TB first, TB last, and TB average. There were no write-back capabilities via the spreadsheet add-in lock and send or the new Smart View submit command. And there was no way of doing complex calculations. But along the way, Oracle has released new features that eliminate many of these limitations. So let's take a look at some of them. In Essbase 9, versions 9.0 through 9.2, many features available in ASO were released. The new features include things like improved restructuring, where now in most cases you could change a database outline and restructure without having to clear the data from the database. That would save a lot of time. It provides the ability to export your level 0 data from an ASO database so that you can easily create backups of your data or transfer that data to a different database. Internal kernel improvements were made to enhance support for deeper hierarchies, more levels, improved database compression, having it take up less space, and a new tool that helps you choose the accounts dimension by estimating what the database size will be depending upon which dimension is specified as the accounts type dimension, which also helps in the compression of the database. Support of duplicate member names was added at this time. Most users don't use it, but it is available. And lastly, the use of substitution variables throughout Essbase was extended so that now you can use them in your member formulas, in your security filters, in rules files that specify the dimension and member names in the data load header and in field specifications for data load columns, and in rules files for the data source name, DSN definitions, associated with the SQL interface. You can use substitution variables within MDX statements, and you can also use them within area and mapping definitions for those of you that create partitions. In releases 9.3 and 9.3.1, even more features were added. Time intelligence, which includes automated time dimensions and expanded functionality of understanding time as a continuum. This allows for the crosstab reporting of time. MDX functions were written to work with time, and you could load data also based on a timestamp. And also a wizard-driven process was created in order to help you create a date-time dimension. Time balance calculations, which don't rely on a time dimension, were introduced so that members of the accounts dimension, can be tagged with time balance properties like TB first, TB last, and TB average, similar to what you might have used in BSO databases. Plus, they added a new flow property, which is used to create cumulative totals from the beginning of the time expressed in the time dimension to the current time member. This was especially helpful in workforce analysis applications. They also added the concept of intelligent aggregations. Aggregate views are collections of members at upper levels that you want to aggregate and store rather than having the aggregate storage database dynamically calculate those members all the time. It adds more space, but it adds speed to your retrievals. Well, the concept of intelligent aggregations provides specific directions to Essbase in the creation of those aggregate views. This provided what are called hard restrictions for a dimension rather than the soft restrictions that were available in previous levels. You could also now do concurrent data loading through the use of multiple data load buffers. To save time, you load data into multiple data load buffers at the same time. An incremental data load feature was added, which allows stream or trickle feeds, which gives you near real-time data access. And it's accomplished by storing data into multiple slices within a database so that you can load data into one slice of the database, trickle feed it, so to speak, without impacting another part of the database. Query cancellation was added, which means when you're running an ESS command script or a MaxL script, you can cancel the operation if it's taking too long or you just don't want to finish it. Things like MDX or MaxL queries, calculations, exporting, restructuring operations, you can cancel those simply by pressing the escape button. Prior to that, you had to wait until that query or calculation finished. And lastly, there's write back to level 0. Although it was undocumented in 9.3.1, it was actually implemented at that time. But one thing to note is that you can't lock the database when data is sent or submitted. So it's not an ideal situation when heavy write back is needed. That brings us to SBase version 11, which adds many more features. Things like partial data clear, where you're going to clear just a certain part of the database. Now you can use an ASO database as the target of a partition, whereas in the past you could only use it as the source of a partition feeding data to another database. Now you can use it as a target. So you can have a BSO database sourcing the data, portions of the data that you see in the ASO database. There are 12 new MDX functions that pertain to retrieving values from the new text list feature in EAS, or returning the database member lists associated with the varying attributes new feature in 11, and some new date retrieval functions. The write back to level 0, it was implemented in 9, but now it's fully documented. And then 2 new features in the recently released 11.1.2 version include custom calculations and MDX formula templates. All of these things we'll be talking about in the upcoming slides. Partial data clear is a new option that enables you to clear a specifically defined region of the ASO cube. So, for example, if you want to clear the budget data for the last 3 months, you can do so by running a script and writing the MDX syntax, as you see here, like clear January, February, March, where you define the region to clear. So you right-click on the database, and in the pop-up menu, you select clear and then partial data, and then specify your MDX set within the clear partial data dialog that you receive. But partial data clearing also allows you to do it in 2 ways: physically clearing the data or logically clearing the data. On this slide, we see the physical clear option, which actually removes the cells in the region that you specify. And so if you report on that area that's been cleared, you will receive your pound missing as usual in the spreadsheet add-in or Smart View. This method restructures the database and takes a longer time, but when done, the database is more compact. So this method is recommended when you're clearing a large amount of data. As opposed to the logical clear, this removes cells by creating a compensating slice using the incremental data load features that were introduced in 9.3.1. And when the user requests the data, they will receive zeros for that data in the cleared region because the compensating slice has compensating negative values in a separate area of the database to compensate for the positive values in the cleared area. This method obviously increases the size of the database, but it takes less time than the physical clear. So it's recommended more often when you're clearing smaller sets of data. The partial clear feature has many benefits. It makes it possible to deal with situations where you only need to clear or delete a portion of the data in the cube. It's much easier than rebuilding the cube or deleting dimension members to remove data. Depending upon your needs, as seen earlier, you can use a logical clear or physical clear. But how do you do it? Well, you use a max-L statement. The alter database statement has a clear data in region clause, which you then specify using an MDX set what region you want to clear. And then at the end of the alter database statement, you either use the physical keyword or eliminate the physical keyword from the statement. And obviously, if you use the physical keyword, it will do a physical clear, and if you leave it off, it will do a logical clear. Now we'll look at a significant enhancement to the S-base partitioning feature. A partition, if you don't know, is a region of the database that's shared with another database. And in prior versions, the full support of partitioning, meaning can something be a source or a target, was implemented only for a BSO database. And ASO could only be the source of a partition, not a target. But in the new version of 11.1.1, the ability for an ASO cube to be the target of a transparent partition was added. So now you can use BSO cubes for the data that needs to have complex calculations done on it. And then the ASO cubes can use that BSO portion as the source for it, so that when you do the reporting in the ASO cube, you get the immediate aggregation performance benefits of an ASO cube, and you let the BSO cube worry about the calculation aspect of things. When using ASO as a transparent target partition, it's possible to have different granularity in the source and the target. As you see here, my quarters have children, my profit have children, my product 100 has children, and East has children, all indicated by the plus sign to the left of those members in the outline. And this is my BSO source data area. And I'm going to feed that data over to the ASO target cube, but in this case my year dimension only has quarters with no months or weeks or days underneath it. My profit is a standalone member, as is my product 100, as is my East market. So there's different granularity between the two. And in this example, you see at this point, the BSO cube is displayed with empty values for January, February, and March, and for the eastern states. There's no totals there. But we can populate the BSO database with the state values in those months and then do the complex calculations possibly required to produce that data to send it over to ASO. But right now, as you see, ASO, my East Q1 number there is nothing there because there's no data on the BSO side of things. But once I load data, calculate that data on the BSO side, then that calculated data, like my East Q1 number of 66,000, is also reflected upon immediate retrieval in the ASO database. The different scenarios for using ASO databases as the target of a transparent partition include vertical partitioning, where multiple cubes are consolidated into an ASO target cube. So I can use different areas of different BSO cubes to feed data into the ASO cube. And the ASO target cube would then display all of the data from the multiple source cubes. And as seen just now, we can also use it with measures that have different granularity. It's possible to have different granularity in the source and the target cubes. That can resolve issues when data needs to be loaded into different levels. An example is when actual data needs to be loaded into a detailed product level, but the budget data needs to be seen from a more aggregated level. Also added were some time intelligence functions, MDX time intelligence functions. There are two date conversions where if you supply a date into the Julian date function, it will return its Julian date equivalent, and the same is true if you supply it to the Unix date function, it will return its Unix date equivalent, which might be important for some people. And there are also a number of functions that return a specific day. We'll see one on this page and a few more on the next page. Like get next day, you don't know exactly what day it is, but depending upon the date given, you will get the next weekday following that date given. So in this example, in the bottom bullet here, I'm using the today function to return today's date. And based upon this number 2, the second argument, that refers to one of the weekdays, Sunday through Saturday. Number 2 happens to refer to the day of Monday, so this function of get next day, today, comma 2, will return the Monday following today's date. Similar functions can return the first day, and they can return the first day of the year, the first day of the quarter, the first day of the month, or the first day of the week, depending upon the date given. Or we can get the last day of the year, quarter, month, or week. Or we can get a rounded date, which converts a given date to the rounded date of the input date. For more information on these MDX functions, I refer you to the technical reference in the that you can get from otn.oracle.com. Select the documentation link on the left, select the Enterprise Performance Management on the right, it's hard to spot. Select the release level library you wish to view, which for many of us might be 11.1.2 now instead of 11.1.1.3, and then select the technical reference link, and finally select contents. It's a long way to get there. And then within the contents of the technical reference, select MDX functions, and MDX functions that return a date. Now we get to the features that were added in version 11.1.2, the most recent release. They include custom calculations. Prior to this release, the only way you could perform calculations in an ASO database was to create member formulas. Now you can do custom calculations, including simple calculations, simple arithmetic, and allocations. The allocation function allows for the handling of debit and credit processing and offsets. The simple custom calculations can include copying data to different parts of the database or simple arithmetic. And you create and execute these calculations using MaxL or the C or Java APIs. These calculations use the aggregate storage load buffer when executed, and the results of the calculations are stored in level 0 cells. So the benefits are that now you can use procedural calculations in ASO databases that were previously only available with BSO. And it gives you another opportunity to take advantage of the scalability and performance capabilities that the aggregate storage model offers. Here's an example of a custom calculation. In this example, we're calculating the budget for the next year. We're going to take the actual data. Here you can see the point of view of actuals November 09 and increase them by 3%, which we'll do in the calculation, obviously. So within this calculation, you assign a source region, my point of view, and my finance, marketing, and leasing areas of my database, shown at the top of the slide. And then you need a calculation itself in the middle, where you see that I'm just taking the actuals for November 09 and increasing them by 3% and storing them into the budget November 2010 target area. So lastly, you need to specify a range of level 0 cells to which the results of this calculation are going to be written. And that's called, of course, the target region. The point of view for the target region is budget November 10, ledger 1, service and maintenance payable. But the level 0 cells reside in the finance, marketing, and leasing areas, the children of those departments. So an example of that is something like this. At the top here, you see the calculation script. My November 10, 2010 budget is my target area of the calculation of adding 3% to my November 9th actuals. I put this script into a text file. And that text file will then be referenced, I should say, as part of the MaxL script. In my MaxL script, I'm going to execute a calculation on my database, which happens to be testDB, but it's going to use a local script file located wherever you specify that it's located. And then you use the POV keyword and a rather lengthy MDX set here to specify the point of view area where you're going to be loading this data at the intersection of these members. And the source region keyword down here is specifying where the data is coming from, November 9th actual, just like it specifies up here. Even though it's specified in the calculation script, it must be specified also within the MaxL script. The target region, however, is optional, and if it's not used, it's simply based on the target that you see in the calculation script. So my target is going to be here, and based upon the point of view in the POV keyword specification. The last thing we're going to talk about are MDX formula templates for aggregate storage. If you don't know, ASO formulas, are member formulas are created using MDX syntax as opposed to BSO member formulas, which are created using a calculation script syntax. The MDX syntax stands for Multidimensional Expression Query Language and is the standard language used for OLAP multidimensional databases. But now for ease of use, member formula templates are available, and you can create other templates so that you don't have to write the complete syntax for the code. You just have to fill in the arguments for the formula rather than the entire syntax of the formula. These formula templates are available in your EAS, Space Administration Services console, which I'll show you in a moment. And there are templates for different types of calculations, including time series formulas. Once a template is created, it's stored in an XML file and then can be opened and edited and used at any time. This is a display of the ASO MDX formula templates dialog that you'll only see if you are at SBase 11.1.2 level. This dialog is opened by first going to the member that you want to create a formula for, right-click on it, select Edit Member Properties. Within the Edit Member Properties dialog, you'll select the Formula tab, and within the Formula tab, you'll see a new button called Member Properties. Rather called MDX Templates. There's a new button called MDX Templates that's available in that Formula tab, which will then display this MDX Formula Templates dialog. As you see on the left, here are the available MDX templates in the Select MDX Template area. And when you select a template, the arguments required are displayed over here in the Specify Variable Elements in the Template area. And you just simply supply the arguments as required, and then the formula that's created from the entry of those arguments into the template is displayed in the formula preview area. And besides just previewing it in this area, you can actually edit it also in this pane. The creation and use of these formula templates can greatly simplify the creation of complex formulas in ASO. So we've discussed a number of things in this webinar. ASO has come a long way since its first introduction in 2005, and the new features include things like clearing partial data, making ASO the target of a partition rather than just the source of a partition, which can help you get data from a BSO database now into an ASO database. There are a bunch of new MDX functions. You can write back to level 0. And as of 11.1.2, you can create some custom calculations and use MDX formula templates to make your member formula creation easier. Thank you for attending the webinar. My name is Craig Messenring. If you have any questions about the webinar or questions about training through HCG, please feel free to contact me at the phone number and email address you see on the screen. Thanks again. I hope to see you again in the future.